I'm Joao Furet Gil, and in this video I'll tackle the Collatz conjecture. First of all, I picked the numbers from 0 to 16 and gave them an index, which is represented in the column list. The pattern repeats every 8 numbers, and encompasses the values between 0 and 7. Then I separated the numbers in blue and in orange. The numbers in orange have an index of 3 or 7. So let's iterate the blue numbers. For the blue numbers, I iterated 3 times. If the number in the third iteration is odd, then one chooses 2 iterations. I chose the numbers in blue in the columns of the 3 iterations, so let's remove the other iterations. The result is always an even number. For the orange numbers, I iterated 4 times, so one picks the orange cell in the iteration columns. There is another list to the left where one starts with the number 0 up to 7. If the number in this list is 3 or 7, then one opens another column starting with the number 0 up to 7. If the numbers 3 or 7 show up again, one opens another column and the process repeats itself. With this method, one assures that the numbers in orange will eventually lead to a number in blue. Let's deal with the blue cells and prove that all numbers lead to the numbers in green, that is, every blue cell is attached to the numbers 1, 2, and 4. Since one knows that these numbers create a cycle, every number in blue should be attached to these numbers, and thus every number will lead to 4, 2, 1. So first we have 1, 2, and 4 in the green cells. So let's try to prove that the other numbers are attached to these numbers. We have 5, 8, and 16. 5 leads to 4, 8 to 2, 16 to 4. So we have 3 more numbers. Then 10, 20, and 21. Then 6, 12, 13, 26, 32, 48, and 64. 17, 24, 52, 53. 42, 44, 45. 9, 14, 22, 25, 28, 29, 36, 37, 38, 50, 56, 58. So all the numbers in green are attached to the cycle 4, 2, 1. Because the list ends in 64, there are some numbers which we cannot prove that are attached to the cycle 4, 2, 1. For example, 30, 33, 41. We have to go on with the list in order to prove that these numbers are attached to 4, 2, 1. So let's tackle the numbers in orange. We have, for example, 3, which leads to 8. 8 is in the position 0, as you can see. 7 leads to 17. 17 is in the position 1. For example, 15 leads to 35, which is in a position 3, which leads to the position 0. When we have 3 or 7, we open a new column in the list. For example, 63 leads to 143, which is in a position 7, then the position 3, and at last the position 0. So this way we can prove that all these numbers will lead to the cycle 4 to 1 because they lead to the numbers, to the even numbers in the green and blue cells. Thus, using this table, one can ascertain that every positive integer will lead to the cycle 4 to 1. So that's it.